Good evening and welcome to the Livingston Parish Algebra 1 EOC review. Today what we're going to do is we're going to do mixed problems from different states. A lot of these questions are kind of on the advanced level. A lot of you have been working hard on your EOC. This will be the last video that we do before we take the EOC. And if you can do these questions as well as all the other ones that we've been working on, you should be able to make it excellent on your EOC. Okay, this first question is completing the square. Completing the square, remember, is a process where you solve 4. And in our class, we had a cheer with completing the square. We said what we did is you half it, then you square it, and then you add it to both sides. So what you do first of all is you take that 4, okay, and you take 4, half of 4 is 2. The next thing you do is you square it. Okay, 2 squared is 4. And then you add that 4 that you squared to both sides. The next thing you do is you factor this side. You think what multiplies to give you positive 4, adds to give you positive 4. And I have a group of live students with me today. They'll be helping me. So class, help me out. What would multiply to give you 4, add to give you 4? That'd be 2 and 2, wouldn't it? Okay, so that'd be x plus 2, x plus 2, or x plus 2 squared. That's why they call it completing the square. Okay? And on this side, 6 plus 4 is 10. Okay, so that's why C would be the answer. No, sorry, CB would be the answer. Okay, now on your EOC, you may have to go a little further. They may ask you to finish completely solve it. So what would you do here to solve for x? You would what? You would square root that side. And if you square root that side, you have to square root that side there, and you have to put plus and minus. So it gives you x plus 2 equal plus and minus square root 10. The final step in solving for x would be what? Subtract 2 of both sides. So it gives you x is equal to negative 2 plus and minus the square root of 10. If you had to go that far with it. Okay. Quadratic formula does the same thing. But anyway, this kind of goes with that. Okay. And quadratic formula is actually derived from completing the square. Okay. Let's look at this one. If x squared is added to x, the sum is 42. What would the equation be? It'd be what? X squared plus x equals 42. That equation is degree 2 or higher. Anytime you have an equation degree 2 or higher, you solve it by setting it equal to 0. So what do we need to do? We need to subtract 42 from both sides. And the best way to solve any quadratic equation, if you can, is by factoring. That's the quickest way. So we would have to think what multiplies to give us negative 42, adds to give us positive 1. Think of your timetables. What would multiply to give you negative 42, add to give you positive 1? Sorry? Okay. Oh, what kind of 7? Let's see. Pick again. Let's see. It'd be positive 7, negative 6, because that multiplies to give you negative 42, adds to give you positive 1. And then remember the zero product factor property. If x plus 7 equals to 0, then x has got to be equal to negative 7, right? To make that equal to 0. Or x has got to be equal to positive 6. So, okay, we know quadratic equations give us 2 answers, okay? And they're only saying here, they're only giving us 1. So which of those is one of our answers? Right, so A would be your answer. Okay, this one, okay, is a review of laws of exponents. Can somebody get us started on this? Okay, so 18, okay, 9 goes into 18, 2, and it goes into 9 and 1. So we're going to have 2 over 1. And then the rule is when you are dividing like bases, you want the exponents should. Okay, so c to the 8th over c to the 2nd would be c to the, okay, on the top. And then d to the 9th, d6, that will be d to the, on the top also. Okay? And which of those answers matches that? Okay, so the answer would be A. Good. Okay. All right. This one, they want us to factor it. And on this one, first of all, I don't see any grades called the factor. I always look for that first one to factor. I don't see anything we can take out. Also notice the leading coefficient is not 1, which means that we're going to have to factor by grouping. Okay, so first of all, 9 times 4 is, okay, what multiplies to give you 36, but would add to give you 12? Okay, 6 times 6, right? Okay, fine. Alright, so what you're going to do is you're going to write 9t squared down, and then you're going to write 4 down. And instead of 12t, we're going to list this, what, 6t plus another 6t, right? And that gives us 12t. Alright, now we look for what these have in common. What do 9 and 6 have in common? 3t. Okay, so we bring 3t in the front. 3t times what is 9t squared? Okay, and then 3t times what would give you positive 6t? Alright, now we go over here and we factor this. What do they have in common? Okay. 2 times what is 16? Good. And then 2 times what is 4? Okay, we're not quite done yet because we're factoring by grouping. Now, what group do these two have in common? So you bring that out to the front. And then what was left over? Okay, that 3t and that 2. Okay, and then look at our answer choices. Which of these answer choices matches that? Right. Okay. All right, this next one. Okay, it says which model correctly represents this product? Okay, you have to remember how algebra tiles work. Remember that was an x squared, that was an x, and that was a 1. Okay, so I think I'm just going to multiply those and see what I get. Okay, we're going to use our FOIL methods. So multiply with x times x would be x times 4 would be 3 times x would be, and 3 times 4 is 12. Okay, and that's going to be what? X squared plus
7x plus 12.
12. Okay, and I have to think now. Okay, first of all, I'm looking for how many x squares? All right, can't be a because there's a bunch of it. Okay, all right, that has 1x squared. Okay, the rest of them have 1x squared. We need how many x's?
7.
And that's what an x looks like. So I'm looking for one of them that has exactly 7 of those in it, and then exactly 12 ones. So what's there? Let's see, that's 1, 2, 3, 4, 5, 6, 7, 8 x's. Can't be right. Which one is it?
D.
It's D, because you got 4 there, 3 there, so 7 x's, and then you got 12 ones. Okay, square root of 18 in the simplest radical form. We have to think of a timetable that's a factor of 18 we can take the square root of. What? A timetable for 18 we can take the square root of. Would it be 6 and 3? I don't think so, because can you take the square root of 6 out of the square root of 3? 9 and 2, right? Because the square root of 9, you can take the square root of that. The square root of 9 is, and then once you get 3, you just bring it out to the front. Okay, so 3 square root of 2 would be your answer. Okay. All right, they want us to factor this one, so we got to think again. What multiplies to give us positive 32, adds to give us negative 12. So what timetable would that be?
4,
Okay, 4 and what?
negative 8.
Okay, I'm going to pause for just a second. Okay, as we were saying, we've got to think what multiplies to give us positive 32 as to give us negative 12. What would that be? That would be what?
4, negative 8.
Okay, negative 4, negative 8. And once again, which of those is a factor? B, okay, is the one that is a factor. By the way, the word binomial means it has how many parts? 1, 2 parts. And actually that has 3 parts. We call that a trinomial. Okay. This is something that is more algebra 2 than algebra 1, but I wanted to talk about it because some states do include it in algebra 1. Anytime we reduce a fraction to lowest terms, first thing we need to do is factor it completely. So let's look at the top here. And what's the first rule for factoring? You always look for a greatest. Alright, so 12 and 20, your greatest common factor is, what's the largest number that will go into both 12 and 20? 4, right? What about a squared and a third? The greatest common factor for them is what? A squared. Right. Okay. So we got to think. 4a squared times what gives us 12a third? Good. Okay. And then 4a squared times what is negative 20a squared? Gotcha. All right. Now the denominator. Okay. What's the greatest common factor out of 16 and 8?
4.
See, 4 is a greatest common factor, but is there a greater one?
8.
Yeah, they have 8 in common. What about a squared and 8? Okay. And we got to think now. 8a times what is 16a squared? Gotcha. All right. And then 8a times what is positive 8a? All right. So you see, now we have it factored, and now we can start reducing. These are multiplies. Okay, so let's reduce. First of all, the 4 and the 8, how can that be reduced? Okay, 4 goes into once, it goes into that twice. Okay, what about a squared and a? That's understood. And first we are dividing on that basis, so we
Subtract from the 8 on the top.
okay, that's going to subtract in the 8 on the top. So we're going to have 1 times a times 3a minus 5. And on the bottom, we're going to have 2a plus 1. And there's our answer, D. So if we're asked to reduce the lowest terms on the EOC, all we do is factor the numerator, factor the denominator, and then do our canceling. Let's look at this one. These were laws of exponents, and we are raising, first of all, a power to a power. All right, and let's think, okay, 3 to the second would be, that would be 9, and we're going to have to pause our video for a second. As we were saying, okay, the laws of exponents, when we raise a power to a power, we what the exponents? Okay, so this would be x, negative 4 to the second power will be x to the negative 8 times 5x to the negative 2. Okay, and then also we know that negative exponents, we can flip those to the other side of the fraction and then make a positive. So 9 times 5 is what? 45. We can flip the x to the 8 and the x to the second, and those exponents become positive. And then I look at these answer choices, and also I got to think when we are multiplying like basis, what do? Right, so the answer is going to be x to the, and so which choice is that? That would be C. Okay. This is something that may or may not be on the Algebra 1 EOC, but some states do include it, so we're going to go ahead and do it. They want you to divide these two polynomials. this goes back to that question that we had a few minutes ago. Divide means, of course, the fraction line. And so basically we're reducing a fraction. This goes back to what we talked about a few minutes ago. And what we need to do is we need to factor the top part and then we can reduce. Okay, so on the top part, no greatest common factor, leading coefficient is not 1, so we're going to have to factor that by grouping again. 18 times 1 is 18. We've got to think now what multiplies to give you positive 18, but add to give you negative 9. What would multiply to give you positive 18? Add giving that negative 6 times negative 3. So what we're going to need to do is we're going to need to do 18 n squared plus 4, and then we're going to need to rewrite negative 9n as negative 6n and negative 3. And we know when we factor by grouping, we put that factor closest to its greatest common factor. So what should we put here, the negative 3 or the negative 6?
6.
So we want negative 6 in here, put negative 3 in here. Alright, so we're ready to factor. Right here, what do 18n squared and negative 6n have in common? 6, what also? What n? And 6n times what gives us 18n squared? And then 6n times what is negative 16? And then here, okay, we know when we factor by grouping, if the first, second, third term is negative, then our greatest common factor will also be negative. I don't see any greatest common factor there, but everything has a greatest common factor of 1, doesn't it? So we're going to put a 1 there. Negative 1 times what is negative 3? And then negative 1 times what is positive 1? Okay? Now if we look at these, what group do they have in common? Okay? And then what's left over?
16.
Right. Now the bottom, the 3n minus 1, there is nothing in common there, so we can just put a what around it. Okay, so what we've done is we have factored the numerator totally, the denominator is factored, and now we can divide, which is another word for just cancel. What cancels or what, okay, what 3n minus 1, they cancel each. So what's the answer? Alright, which graph best represents this function? Well, first of all, we know that if we multiply that out, is it going to be linear or quadratic? Multiply x times x, that's going to be x squared plus a bunch of other stuff, right? So is that linear or quadratic? So we know it cannot be C or D. Since it's already in factored form, we can look for the zeros, where this is equal to 0 by our zero product factor property. Okay. What 0 do we get out of that factor? Positive 2. And what 0 do we get out of that one? Okay, and we know the zeros are always where that parabola is equal to 0, crosses the x-axis. Okay, and so our answer is going to be A or B? Okay. Because 2 is a 0, negative 4 is a 0. Another thing that you could have done, that I almost started doing, is distribute this out. Let me distribute that. That'd be x squared, what else? Plus minus 8, or x squared plus 2x minus 8. In this form, which is called standard form, it's easy to see the y-intercept. What's the y-intercept going to be? If x is 0, y would be negative 8. And if you look at this one, the y-intercept is negative 8, isn't it? Okay? And there the y. So that would be another giveaway. That will be the answer. Okay, number 12. almost freed that one. Okay, if something is increasing by a certain percentage here, remember in the springboard book, there was a lesson on protecting your investment, but the value of a house, and the value of the house kept going up. And remember that was exponential. And remember exponential, the way you do that is, okay, it's y equal to your initial value times your percent, okay, to the number of years. Okay, so in this one, how much is he depositing? Okay, so he's starting out with $100. Okay, and let's see, it's increasing by 5% each year. What's that as a decimal? Okay, now when he puts his money in the savings account, does he still get the money he put in there back? He does, doesn't he? Okay, plus he gets 5% more each year. In other words, he's going to get 1 plus 0.05 each year for X years, as long as he leaves it in there. Okay, so the function for Tom is 100 times 1.05 to the X power. Now, Christy is in a different thing, and okay, this is a weird savings account for Christine. Okay, she's going to put $100 in, and it's only going to increase by 5 each year. That's going to be what? 5 times X, where X is here. That's linear, isn't it? Okay, all right. So A would be your answer. Let me ask you this also. Who's going to make the most money, Tom or Christine? Okay. Our kids is going to be growing exponentially. Okay, remember exponential functions, they start and once they go, they really take off. Okay, whereas Christine should be making money, but it's going to be linear. She's not going to nearly have the money that he does. All right, I have a system of equations here. They want to know the value of X for a system. But when we solve systems, then what we need to do is we need to put both of them in standard form. We need to line up the X's and the Y's. So what can we do to that equation right there to get it in standard form? We need to get this negative X over there with the Y. Okay, so we can add X to both sides. So it's going to give you X plus Y equal to 2. The bottom one is already in standard form. They want the value of X, so we need to eliminate the Y's. That's positive 4. We need this to be what? Okay, what can we do to this top equation so that'll be negative 4y? Very good. So multiply this side by negative 4, that side by negative 4. So when we do that, that's going to be what? Negative 4x minus 4y, because we have to distribute that, is equal to negative 8. The blue equation, we're going to leave it like it was. And we combine negative 4x plus 7x is what? 3x. This cancels, and negative 8 and negative 1 add to give us, okay, what's the next step? And we get x equal to negative 3, which is choice B. Now, they may ask you for y also. How would you find y if they wanted to know it? Right, does it matter which equation you choose? Okay, usually we go with the one with the easiest numbers. So if you wanted to find y, probably the red one or the blue one would be the best one. Okay, so add x plus y equals 2. We just found out that x was negative 3. What would we do now? We would add 3 and get y equal to. So if you were graphing these, at what point would those two lines intersect at? They would intersect at what point? Negative 3 5 would be the point of intersection. See, there's several different ways you can be asked this for your EOC. All right. This is something that some states do, matrices. All that is an organized list of numbers and they want us to add them. Okay, so what you do is you take them one at a time. 2 plus 5 is 7, so that goes in that spot. 1 plus negative 6 is, that goes there. 4 plus 7 is, that goes there. 0 plus 2 is negative 3 plus 5 is, and then negative 3 plus 1 is, okay, all right. And if you look at the choices, which choice is that? Okay, that's choice C. Okay. Let's talk about our properties. And go for our steps. And I'm going to pause the video and start recording. Okay, we're back, and we are talking about what property of real numbers justifies the work shown. Okay, first of all, we see step 1. Okay, what we've got here is they are showing, you've got this situation, and basically what's the difference between step 1 and step 2? What did they change? They changed the order, okay? And, okay, it was this first, then that, now they switched the order. Okay, and which of these properties is about changing order? Commutative, associative, identity, or distributive? Now, identity is not means. Identity means like if you add 5 plus 0, you still get 5. That's not it. Okay, the answer is commutative. Okay, commutative property is where you have a change in order. So A would be the answer. Associative would be where you have a change in grouping. If the order was changed, so that would be commutative property. Associative would look like this. If you wanted to show the associative property. That is still true, isn't it? Okay, but now 12x and 15 were in that group. But you notice what's in the same group now? Okay, so that is the associative property. Because you changed the group. Okay. And let's see. We are completing the square, so we have to review that process again. Remember, with completing the square, you begin by putting all the x's on one side. You move the number to the other side. And we have a cheer for that. Okay, what do we do with that negative 10? We? Okay, so what's half of negative 10? Okay. And then what do we do with negative 5? We? Okay. What's negative 5 squared? And then what do we do with 25? We?
Add both sides.
So add 25 here, add 25 here. Now we factor this side. What multiplies to give you positive 25 as to give you negative 10? What multiplies to give you positive negative 5, negative 5, or x minus 5 squared. And then what's negative 8 plus 25? Okay, so looking at the answer choices, that would be choice B. Now, on the EOC, they may ask you to go ahead and finish solving. How would you solve it now for x? If you square root that side, you've got to square root that side, and you also got to put what? Plus and. So you get x is equal to, okay, that's x minus 5. 5 equal to plus and minus square root of 17. Last step is to add 5. So your x is equal to 5 plus and minus the square root of 17. On the calculator part of your EOC, they may ask for the decimal approximation. So they may ask you to type that in. Let's get our calculator out real quick and let's approximate this using our decimals. Calculator. Okay, you want to do negative 5 plus the square root of 17. Press enter. And that would give you this answer. What would that be rounded to the nearest thousand? It'd be what, negative 0.8777. That was using the plus. Now let's use the minus. So we want negative 5 minus the square root of 17. And what would that be rounded off to the nearest thousand? Right, negative 9.123. So be prepared, okay, with your calculator. Make sure that you can get these answers, okay, both in, this is called exact form. It's also called simplest radical form. This is called approximate. Because we approximated to the nearest thousand. Okay, this concludes part 1 of our video, which was mixed review questions from mixed states, questions 1 through 16. Thank you for watching our show.